Okay, so we're going to go through some revision for getting ready for a mini test, guys. And we've got to first remember how to simplify. So we've got to remember that adding letters with like terms. So these are about 3Gs, so 3Gs, and this is about 5Gs. So how many Gs do we have to altogether? 1, 2, 3, 4, 5, 6, 7, 8. We could just realise that we do 3 plus 5 as well. So simplifying that would be 8G. We've written less. Here we've got to remember that we can swap the order of multiplications to anything we like, because it's what's called commutative. 2 times 3 is 6 and 3 times 2 is 6, so it doesn't matter which way around we do it. So we can swap these around. So 2 times 5 is 10 and r times p is rp. So 2r times 5p will equal 10rp. Expand. Remember, it means that whatever's outside the bracket, you multiply everything inside by it. So this is saying 5 times 2y and 5 times 3. So 5 times 2y is 10y and 5 times 3 is 15. But we've got a minus sign in there, so it's going to be still take away in the answer, because there's nothing to change that into a positive or anything. So 5 lots of everything in that's inside the bracket. That's what expanding is about, when you've got brackets there. The next one has got that 2 single brackets, so we do each bracket one at a time and then work it through. So this is saying 2 lots of everything inside here, so 2 lots of that and 2 lots of that. So 2 lots of 3x is 6x, 2 times 3 is 6, and 2 times 4 is 8, and it's plus 8. Here we've got to be careful. Quite often it's easier to think of this as negative 3. So if we think of that as negative 3, then we're doing negative 3 times this. So negative 3 times positive 4 is negative 12, but it's about x's, so it'll be negative 12x. And then we've got negative 3 times, here again, if we think of this as negative 5, it helps us to see how the minus signs come together. So this is like saying negative 3 times negative 5. Well, a negative times a negative makes a positive. So this is going to be 3 times 5, 15. So just got to be careful with the minus signs that are involved, that we treat them as we should do to get the right operations in front of the terms as we do each of the bits. So again, adding and taking away can be done in any order. So I can do, if I've got 6 take away 8 is the same as 8 take away 8 plus 6. So I can swap the order as long as I keep the operation signs with the number to the right, of course, or the term to the right. So here I can swap this about. So this is going to be 6x take away 12x, again keeping the sign with the term to the right, plus 8 plus 15. And then I can see that I've got to do 6x's take away 12x's. Well, that's going to take me into the negatives, so it's going to be negative 6x, because if you remember what that looks like on a number line, doing 6 take away 12, you're going to go past 0, and you're going to go to negative 6. And then you've got positive 8 plus 15, so that's going to make plus 23. Factorize, it's that thing about finding factors and putting things into brackets. So we recognise that both of these terms have a common factor, so it'll be a single bracket factorisation where outside the bracket will be the highest common factor of all terms. So if we look at this, then we've got a p goes into p squared and a p goes into p. There isn't a number in front of p squared, technically there is 1, so it's 1p squared, but there's nothing that'll factorise with the number bits apart from 1, which doesn't change it. So, and then we think to ourselves, what do we multiply p by to give us p squared? So that's going to be p times p, gives us p squared. And then what do I multiply p by to give me 6p? Well, I'm going to multiply by 6, and it's a plus in between, so plus in between. And I check by multiplying back out, expanding the bracket. So p times p is p squared, and p times 6 is 6p. So the check kind of works. And this question is asking us to expand and simplify involving 2 brackets. There are lots of methods for doing this, but I prefer a grid, but there's foil, there's a smiley face, there's all kinds of things you could be doing with this. But if you remember, you take the first bracket and x, 7, just put a little plus sign above it to remind yourself that it's a positive 7, and then we've got x in the second bracket and then we've got 4, but again we've got a minus sign to front of that, so we've got a little sign there to remind us that we treat that as -4. And it's a times grid, so we're going to remember everything is being multiplied. So we're doing x times x, which is x squared. We're doing -4 times x, which is -4x. Then we're doing -4 times 7 to give you this one, which is negative times a positive is a negative. 4 times 7 is 28. And then we're doing x times 7, which is 7x, but it's a positive, so positive 7x. And then we write out what's inside the grid to look to see if we can simplify anything down. So we've got x squared plus 7x, take away 4x, take away 28. Again, we can treat those negative signs as now takeaways when we're bringing together our terms into the expression. So we've got an x squared, we've got 7x's take away 4x's, which will leave us with 3x's, and then we've got take away 28. So that's how that could be done. Again, we really ought to be in the habit of checking. We may not write down our check, but at least we think it through. So if I said what happens when x is 5, then the two brackets here will become 5 plus 7, and then it's 5 take away 4. So this is 12 times 1. And then if I put 5 in here, then we end up doing 5 squared plus 3 lots of 5 take away 28. Well, 5 squared is 25, 3 5s are 15, take away 28, well 25 plus 15 is 40, take away 28 is 12. So both of these gave us 12, so our check kind of worked. So our final answer on the dot line then is x squared plus 3x take away 28. So that's a reminder of how to multiply out two brackets. Write the first bracket across the top of the grid, write the second bracket down the side of the grid. It's a multiplication grid, so you've got to remember to multiply everything, but quite important to keep the operations in front of the numbers, so you can think of them as positives when it's a plus in front, and you can think of them as negative when it's a minus in front. And then when you're doing your multiplications, you can be thinking about it's -4 times positive 7, so it's going to be -28. A negative times a positive is a negative answer. Okay. Alright, so now we go on and we're looking at making something that's subject to the formula. So as we can see on the answer line, it's saying to us that we should end up with an answer of u equals something. So we need to be swapping this about until we get u on its own. So if I write that a little bit bigger so I can identify what I'm doing. So the way I tend to think about these guys is I want u as a subject, so I want to leave the u where it is because it's already positive. Now if that had a minus in front of it, then I'd have to move it across here first to make it a positive thing. But at the moment that t's in the wrong place, that doesn't need to be there because I want to leave u on its own, and the whole of that is in the wrong place. Now I'm saying the whole of that, remember, because it's got nothing to do with u and it's got a plus in front of it, so therefore it's a whole term. And quite often you can move a whole term if it's not involved in the letter that you want as a subject. When we move things from left hand to right hand, so we tend to think of this as a left hand side and right hand side of the equals. So this needs to move, so it needs to become 0. So the opposite of adding is taking away. So we're going to take away kt squared from that side, and then we're going to take away kt squared from that side. Important that we remember that when we're writing the next line of our answer, we come top downwards. So we always start with the top bits and then come down and write down what we see. So here we've got d take away kt squared. We still haven't done anything with the u and the t, so we leave that as ut. But this is positive kt squared, take away kt squared, which means that's gone. So it's moved away and becomes 0. So we're trying to get u on its own, so the only thing to move now is this t. These two, when they're next to each other, is telling you to times. So to move something, you have to do the opposite operation, so we're going to divide by t. And in doing that, we're doing t divided by t, which is 1. So we'll have 1u, which is what the answer needs to have, 1u. And again, we come top down, so we write down what we see. So we see d take away kt squared. So it's d take away kt squared. And then it's saying divide by t. So it's the whole of that divide by t, because that was first. Excuse me. Okay, so making something the subject, we want the subject letter on its own, and we move everything else to the opposite side of the equals that the subject letter's on, and we do the movements by doing the opposite operations. Okay, so another example of making something the subject. So here we want to make t the subject. So again, if I write this out a little bit bigger so we can see what we're doing. So because we want t as the subject, that means the 5 needs to move and the u needs to move. Now, because the u isn't part of the term involving the subject letter, we do that first. So to make this u become 0, we take it away. So we take away u from there as well. U take away u will be nothing, but then we have v take away u. And we're left with 5t. Don't need to write the plus sign in front of it because we know that it's positive. The 5 is the only thing that's left then to move, and because that says timesing, we move it by dividing. 5 divided by 5 is 1, so we'll end up with 1t left here, but whatever we do to the right hand side, we must do to the left hand side. So we end up with t is equal to v minus u all over 5. So that's a quick reminder about rearranging formulae and making something a subject by moving things in the opposite operations. Okay, so we move on to do some practice of solving simultaneous equations. So the key thing about solving simultaneous equations is we have two letters to find the value of, so we need two equations, and we have to go through the process then of manipulating these to remove one of the letters to find the value of one letter, and then once we've got the value of one letter we can put it back into the equations to find the value of the other letter, and then both equations should work with the same a and b values. And they have to happen at the same time, the idea of being simultaneous. So the first thing we do is we look to see whether either variable has the same number in front of it. So that's got 5 a's, that's got 2 a's, they're different. This one's got 3b and this one's got 3b. That's the same number in front. Different operation happening now. This is a positive 3 and this is a negative 3, but that doesn't matter. It's about having the 3b's and the 3b's, and then we can deal with the plus or minus to make the b term disappear. So in this particular example, we've already got the same number in front of the letter, so we can automatically go to the next stage of solving simultaneous equations, which is to ask ourselves, can we add the equations or can we subtract the equations to eliminate the term that we want to? Well, we can see here that if we can do 3b, take away 3b, then the b's will disappear, the b terms will go to nothing. So we'll have to do a addition here because we need to end up adding these two terms to make it 0. So we'll end up with 3b plus take away 3b. We're adding the terms, but the plus and minus, if you remember, because you're adding a negative or adding a take away, then you're going to get smaller. So it's like saying 3b's take away 3b's, which equals 0. So the term's gone. So we've got 5a plus 2a, which is 7a, and we've got 9 plus 12, which is 21. So we've got 7a's worth 21. And to get 1a, which is what we need the value of, then we're going to divide by 7. 7 divided by 7 will be 1, 1a. But we have to do the same to the other side as well, because solving equations is just like rearranging, really. You just want the letter that you're trying to find the value of as the subject. So we want it on its own. So we end up with a is equal to 3. Now, once we know the value of one of the letters, we put a equals 3. Or substitute, whichever way you like to think about it, so putting it or substituting it. So we're substituting the a equals 3 value into one of the equations. Now it doesn't really matter which equation we choose because it's got to work for both anyway. That's the aim of simultaneous. So I'm going to put it into the top one. So the top one tells me that I'm doing 5 lots of the a value, so 5 lots of 3. I'm adding 3 lots of the b value, and I want the answer to become 9. So 5 3's are 15 plus 3b equals 9. Now, because we want b, the answer for b, what value will make this work, then we rearrange this to leave b where it is. So we're going to take away 15 from both sides, then that's going to leave us what 3b's worth. So 9 take away 15 is negative 6. Just remember what we're doing here, guys. 9, 0. If we take away 9, we've got to 0, but then we'll have to carry on taking away 6 more until we get to do the take away 15. So we'll end up at negative 6. We know what 3b's are worth, so we want one of them, so we divide by 3, and we find that b is worth negative 2. Now, with these simultaneous equations, it is really important you check in the other equation. So we already used the top one, so we're going to check it in the second one. So the second one said 2a take away 3b should give us an answer of 12. So we substitute the values that we think we know. So we know, well, we think the a value is worth 3, so we substitute 3. And we think the b value is worth negative 2, so we substitute that. So 2 3's are 6. We've got here, again, it's quite useful to think of this as negative 3. So we've got negative 3 times negative 2, and negative times a negative is a positive, so we end up adding. So 6 add 6 is 12, which is what we wanted. So we're confident then that the values work. So our A value was 3 and our B value was -2. Okay, so move on. We've got to solve a simultaneous equation again. We know it doesn't say the word simultaneous, but we know it's simultaneous because it's got two equations with two letters. So therefore we've got to go through the process. We ask ourselves, does one of the letters have the same number in front of it already? This has 2 in front, 5 in front, this has 3 in front and 2 in front, so no. So therefore we're going to have to manipulate these equations. So if we call this one equation A and call that one equation B, we want the same number in front of the letters. So we can either make the x's have 10 in front by multiplying the top by 5 and multiplying the bottom by 2. Or we could make the y's have 6 in front, because the multiples of 2 and 3, 6 is the lowest common multiple. So we could multiply the top equation by 2, and that'll give us 6 there, and we could multiply the bottom equation by 3, and that'll give us 6 there. It really doesn't matter which way you do it. I'm going to stick to the front. It tends to be a more straightforward method then. So I'm going to do the A equation times 5, so that's going to give me 10x's, because you multiply every term by 5. So -3 times 5 is -15y, and 5 times 11 is 55. And then I'm going to take the second equation and double it, because that will then give me 10x's there. Double 2 is 4y's, and double 18 is 36. So we've got two new equations, so equation C and equation D. We've got a situation where we can get the x terms to cancel each other out by doing a subtraction. So again, we'd ask ourselves, would we add or take away to make the term that we've got the same number in front of become 0? And in this case, 10x's take away 10x's work. So we've got 10x take away 10x, which has made the x's disappear. It's gone to nothing. Here we've got to be careful, because we're doing -15y's take away +4y's. So it's like saying we're doing -15 take away +4. And then what we've got to remember is that when we take away a positive, we end up going smaller, we end up taking away. So we end up doing -15 take away 4, which is -19. So here we'll have -9y's, and that equals, well, we do the number terms, so we've got 55 take away 36, which is 19. We want to know the value of y, so we need to divide by -19, but we do the same to both sides. So we divide by -19, and -19 divided by -19 is +1, so that gives us our +1y. And 19 divided by -19, we've got to be careful, is -1. Positive divided by negative is a negative answer, so -1. And like all simultaneous equations, once we think we've found the value of one letter, we put it back into one of the equations to find the value of the other. So I'm going to use the top one. So we've got 2x's take away 3 lots of the y value, so that's going to be 3 lots of -1, and that's supposed to equal 11. So we have 2x's. Now again, we've got -3 here times -1, which makes +3. And then we're trying to find the value of x, so we rearrange by doing the opposite operation. So we take away 3 from both sides, so we end up with 2x is worth 8, 11 take away 3 is 8, 3 take away 3 is nothing, so that's left us with 2x. We want the value of 1x, so share by 2 will tell us the value of 1x. 2 divided by 2 is 1, so we've got 1x, and then we have to do the same to the right hand side. 8 divided by 2 is 4. So we now think we know the values of x and y. We think x is worth 4, and we think y is worth -1. But again, it's so important with simultaneous equations that you check that you haven't made any silly errors with your positives and negatives, and you must check in the equation you didn't use to find the value of the letters. Now, we haven't used equation B to find the value of the second letter, so we're going to check in B. So B says we do 5 lots of the x value, well, we think the x value is 4. We're adding 2 lots of the y value, which is -1. So we've got 5 lots of 4, which is 20. We've got 2 lots of -1, which is -2. Adding -2 means we're going to get smaller, so we do a takeaway. And 20 take away 2 is 18. And when we look back at the equation, we can see the value that we expected for equation B was 18. So our check worked, and we can be confident to write on the answer line the answers. So x is worth 4, and y is worth -1. Okay, so just remember with simultaneous equations then, you need the same number in front of one of the letters to be able to go to the next stage of trying to solve it. and sometimes you've got to manipulate both equations to get what you need. I wanted 10x in front of both, so I had to do something times a and something times b to get that to happen. Sometimes you only have to multiply one equation, and as you saw on question 5 a minute ago, you only had to go straight to adding because both equations had the same value in front of the letter already. Okay, so question 7. It's talking about a right angle triangle, and it wants us to work out a length, and they've given us 2 lengths already. So the clue here then is, isn't it? It's a right angle triangle, they're asking us to find a length, and they've given us 2 lengths. We'd normally ask the question, do we use Pythagoras or Pythagoras theorem, or do we use trigonometry to work with right angle triangles to find missing lengths? Well, this has got 2 lengths, so it's Pythagoras. So the thing to do is remind yourself what Pythagoras' theorem is. So C is always labelled for the hypotenuse, the longest side of the right angle triangle, and then A and B are the 2 short side lengths. And what Pythagoras discovered was that if you take the square of one side, add it to the square length of the other side, then it always equals the longest side squared. So in this particular question then, this is our long side, that's our C value, this is our B value, and this is our A value. So we go through filling in Pythagoras' theorem using what we know. Well, we don't know A yet, so that's still going to be A squared. We know the value of B was given us 6, so that's 6 squared, and we know the value of C was given us 9, so that's 9 squared. And we then work out what each of those give us. So 6 squared is 36, 9 squared is 81. Now, because we want A squared, and then we want the value of A, the plus 36 needs to move to the right-hand side. So to do that, we have to subtract it to make it nothing. And we do the same to both sides, so we do a subtraction on both sides. So we end up with A squared, well, 81 take away 36, well, 81 take away 30 is 51, and then take away 6 more is 45. Do a back check, 40 plus 30 is 70, 5 plus 6 is 11, 70 plus 11 is 81. Yep, so A squared equals 45. But the question said work out the length of AB, which we've labelled as little a, so we need to square root this to get the actual value of A itself. So A is going to be the square root of 45, so we get our calculator, and we know the answer is going to be roughly around 7, because the square root of 49 is 7, so we do our estimate in our head just to make sure that we've not pressed wrong buttons on our calculator. So the root of 45 is 6.708. We then look back at the question, and it says it wants the answer to 3 significant figures. So we must remember then that we find our first significant figure, which is the first non-zero digit in the number. So that's our first one. So that'll be our second one, that's our third one. So it's telling us to cut the number there. So we ask ourselves, does the next digit tell us that we're halfway up? Yes, we are, with 5 or more. So this is going to be 6.71 centimetres. The units have been given, but always watch for that, because sometimes the examiners like to be clever and they miss that out, and you're expected to remember to do it. So always put the units down, whatever, and then you can never forget. Okay, so Pythagoras, because we recognise we had a question with right angle triangle involving 2 lengths already, and we needed to find a third length. Okay, so question 8 goes on and talks about a list of numbers, and it's about homework marks, and we've got to write down a mode average. So the mode average is the most frequent, so it's that word most often, it occurs the most. So the most frequent number in the data. So when we look at this list then we can see there's 1, 2, 3, 4 5s, 1, 2, 3 4s, so it must be 5 because that happens more. It says then work out the median average mark. Well, we've got to remember that the median is the middle data point when the data is in size order. Okay, that's quite important. So we need the middle data point when the data is in size order. At the moment this data is not in size order, so we need to rearrange it. So 1, 2, 3, 4, 4, 4, 5, 5, 5, 5. Okay, then we do a check. There was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 homeworks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 homeworks. Okay, so we've got the 10 numbers written out in size order. The median is the middle data point. Well, when you've got an even number of numbers, there's going to be a middle pair, because you'll need the same number of numbers below the middle bit and the same number of numbers after the middle bit. So there were 4 numbers before the middle pair and 4 numbers after the middle pair. And once you get the middle pair, we definitely still want to be in the middle, so we have to go in the middle of those two numbers. Well, between 4 and 4, well, we haven't moved, we're still at 4, so the answer here will be 4 marks. Okay, we should have put marks there, of course, because we really ought to say what the units are for the question. So the median average mark was 4 marks. It then says work out the mean for the homework mark, and we need to remember then that the mean is defined as the total of your data. So in this case it's the total of all marks, and we're going to divide by the total frequency. In other words, the number of numbers that gave you the total marks. So the total marks then, we're going to add up these numbers. So I'll add up this list here because it'll be easier if they're in size order. So we've got 4 5s, which is 20, 24, 28, 32, 35, 37, 38. So our total marks was 38, and the number of numbers, so the number of homeworks was 10. Excuse me. And 38 divided by 10 is 3.8 marks. Now in our head we should check that it's sensible. So check the mean average is sensible. Now what that means is that sometimes you forget that you need to divide by the number of numbers, and you might just divide by 4 if there's 4 rows of data and things like that, and the number you get just isn't part of the data set, so it's too high. So when we look at this, 3.8 is in the data, it's around here, so it seems sensible that will work. Okay, so that's a quick recap of the averages for lists of numbers, and now the next question is asking us to work with averages for a table of data, a frequency table. So we need to remember how frequency tables work. So this is saying that there was 2 boxes of drawing pins with 29 pins in, 5 boxes of pins with 5 boxes with 30 pins in, 2 boxes with 31 pins in, and so forth. So key with this is that we need to know how many boxes there were. Now the question told us, anyway, we read it carefully, but we need to know what the total frequency is at some stage. We're going to need that to work out medians and things and our means. So let's have a look what the question says. It says write down the modal number. Now modal is just another fancy way of saying mode, so most. So we're after the one that happens the most, so the most often. And when we look at our frequencies, then we can see that that happened twice, that happened 5 times, twice, once. So it's this one here, because it happened more times, and that had 30 pins in it, because the question says what's the drawing pins, the number of drawing pins. So 30 pins is the modal average. It then says work out the range of the number of drawing pins. So we've got to be careful we read the question. It says work out the range of the number of drawing pins. So all we're interested in is the number of drawing pins. And we need to remember that the range is about high-low, so range high-low, which means that basically you do the max value minus the minimum value. So the highest value, take away the lowest value. The max number of drawing pins was 32, and the minimum drawing pins was 29. 32 take away 29 is 3. So the range was 3 pins. So from the smallest to the biggest, there's a range of 3 pins. So there's a narrow range in this case. It then says work out the mean number of drawing pins. Well, just like previous question, the mean is going to be the total number of pins, because this is about drawing pins. So we need the total number of pins, and we need to then divide by the total number of boxes, because it's about mean average per box. So we need the total number of boxes. So to get the total number of pins, then we need to remember that this is telling us that there's 2 boxes with 29 pins. So we'll end up having to do 2 times 29 here, because what we're going to do here is work out the number of drawing pins. And we do that by taking the number of drawing pins, which we could call x, our data variable, and we times it by the frequency. So literally we're going to go through and we're going to times all of these across to work out the number of drawing pins. So here we've got 5 times 30, here we've got 2 times 31, and here we've got 1 times 32. So 2 29s 58, 5 30s 150, 2 31s 62, and 1 32 32. So we're going to have to add up to get our total number. So this will give us our total number of drawing pins when we add them together. Okay, so we've got 208, 210, 270, 300, 302. So we now know from the table what the total number of drawing pins was, so we can go back to what the mean is actually asking us. It wants the total number of pins, so 302, and we divide it by the total number of boxes, which is 10. So 30.2. Now I know you could say that you can't have a decimal point or a point of a drawing pin, but mean average, you are allowed to have decimals in your answers because it is a typical average. It's what's happening typically across all the boxes. So we're saying that just over 30 pins per box, and again it's 30.2 pins. Okay, so mean average. Right, so this question goes on and talks about working with a right angle triangle, and we've got to work out the length of this side here. So it's a right angle triangle involving an angle and a length. So we'd ask ourselves, could we use Pythagoras? No, because we don't have two lengths. Therefore we're going to be using the trigonometric ratios, so the topic of trigonometry. And there's lots of ways of doing this. So a lot of people think of so, car, toa, and they might think of writing it in triangle form to try and help them to remember how you're going to work with the ratios, whether you're going to be timesing or dividing. So times if you go that way, and because they're on top of each other, divide if you go that way. So we're going to look at labelling this triangle up, because the S stands for the sine of an angle. Theta is the special symbol we use for representing an angle in a question or in a triangle, and theta in this case is 38 degrees. So S stands for sine theta, C stands for cosine theta, and T stands for tangent theta. So these are just ratios that have been found to work for right angle triangles of any size, and the O is for the opposite length, the H is for the hypotenuse length, and the A is for the adjacent length. And basically what we've got to remember about the trigonometric ratios is that we're working with the idea that we have a right angle triangle with some angle theta, and theta's there, so this is known as the opposite length. The right angle's here, so this is the hypotenuse length, and the adjacent means next to. So basically we label up the hypotenuse as H, the opposite side as O, and the adjacent length as A. And once we've labelled our triangle up, we can then decide which ratio will work for us, and then we can rearrange that ratio accordingly to get the answer needed. So if we go back to the question, we can see our theta's here, so this must be the opposite length because it's opposite the angle we're working with. Our right angle's here, so the opposite length to there is the hypotenuse, the longest side, and this side is next to the angle, so this is going to be the adjacent length. So we've now decided what the labels do. The question wanted the length of AB, so AB is here, so this is our question mark. So we look at what we know. Well, we know the length of A, so we can think that, yeah, we might be using one of those two ratios then. But we need to find the value of O, the length of AB. So the only one that involves those two things, what we know and what we need to know, is TOA. So that means we're going to use the tangent ratio. So we write down what the tangent ratio is. So the tangent ratio says that we take the tangent of the angle and it equals the opposite length over the adjacent length. We fill in the numbers we know. So we know the theta was 38 degrees. Opposite length is what we need, but we do know the adjacent length was 8.5. And this topic again relies on you thinking about your rearranging. So we want the opposite length to be the subject. So this 8.5 has got to move across to the left hand side. This says divide. So the opposite of doing this is timesing. So we're going to times by 8.5. So that means we'll have 8.5 times the tan of 38, and that will give us the length of O, our opposite length. So we get our calculator, and we really make sure that it's going to work properly by making sure that it says either the word deg or the letter D in our screen. So this one does. If it doesn't, then you need to reset your calculator to make sure you get it back into degrees mode. And we then type in what the question wanted as an answer. So 8.5 times, press the tan key, 38 degrees equals. So 6.64. Now, if you prefer triangle approach to working with three-letter formulae, then you could have written this out as the tangent of the angle is equal to the opposite length over the adjacent length. And you could have said that you wanted the opposite length, so cover that up. And then, of course, we've got these two next to each other, so we'll end up timesing the two things, as we've done here. The adjacent length times the tangent of theta. If for some reason we wanted the adjacent length, then these two would have been on top of each other. So it would have told us to do the opposite length divide by the tangent of theta. So lots of different ways you can think about using these ratios to find the missing numbers. So that's an example of how to find a missing length using the trigonometric ratios. This question wants you to find an angle. So basically it's saying to you, here's a right angle triangle, we've got to find this missing angle here. Well, again, right angle triangles with angles and lengths, it's not going to be Pythagoras because it's about an angle, so it must be one of the trigonometric ratios. So the thing we have in mind is SOLCAR-TOA to then decide which ratio we're going to use. And again, if you like triangles to help you find missing things, then you could write out your triangle, cosine of the angle A over H, tangent A over H, and so forth. So we go through the usual thing then. So we've got to label this triangle up. So just like the previous question, we have a standard layout for the right angle triangle. Wherever the theta is the opposite length. Wherever the right angle is, the opposite is the hypotenuse, and the adjacent is the one next to the theta. Well, this is our theta, so that's our missing angle to find. So this must be the opposite side O. This is next to the angle that we're trying to find, so that's our A. And this is the longest side, so our hypotenuse. Like all these kind of questions with the ratios, we ask ourselves, what do we know first? Well, in this question, we know the length of O and we know the length of A. So we know the length of O and we know the length of A. So automatically, we've got enough information. We've got two things in this rule here. Then we can use this one to find the missing answer. This one, we'd only know O, and this one, we'd only know A. We wouldn't know the hypotenuse length. So we can't use either of those two straight away. We could find the hypotenuse length if we wanted to by Pythagoras and then choose to use one of these, but that'd be extra work for no reason. We've already got a ratio where we know the two lengths needed. So we write out the ratio. So the tangent of the angle is equal to the opposite length divided by the adjacent length. And the only thing you've got to remember about this one, guys, is that when you want an angle, you'll notice on your calculators that your cos, tan and sin keys, they have above them what they call the inverse functions. Sin to the minus 1, so the inverse of the sine function, cos to the minus 1, the inverse of the cosine function, and tan to the minus 1, the inverse of the tan function. And these inverse functions allow you to find missing angles. So basically we're going to say that theta, because we want the opposite of the tangent function, to leave theta as the subject, is going to be the inverse tangent of the opposite length over the adjacent length. So that's going to mean we're doing tan to the minus 1 of the opposite length, 5, divide by the adjacent length, 12.5. So we put that in our calculator, again making sure that we're in degrees mode, open a bracket, 5 divide by 12.5, close the bracket, equals. So we get an answer of 21.8 to three significant figures. So 21.8 degrees. Okay, so that's the answer for question 11, and it's reminded you hopefully on how we can use the trigonometric ratios to find missing lengths and angles in right angle triangles. Alright, good luck on your homework, guys.